All right, so the second part of our weather and climate lecture, we're going to talk about more interesting weather things. But first, let's just wrap up about winds and a couple things in the atmosphere. So we have jet streams. Jet streams are really high speed currents of wind, and they can really change the local weather of an area. So whenever we have a cold snap here in San Antonio, when a cold front comes in really quickly, that's usually because the jet stream to the north of us, way up in Canada and the polar regions, gets pushed down south for pressure differences, and we get a big bunch of that cold air down here. And that's usually like the first big cold snap. That's what that's caused by. These next few slides are just some pictures that show you some general wind patterns and all that kind of stuff. You don't really need to know these by any means. It's more for your reference than anything. This one as well kind of goes through and shows you different directions of things and where they lie with the latitudes. All right, now let's talk about the fun stuff. So we're going to talk about different weather events. So like what's the difference between a monsoon and a typhoon and a hurricane and all that stuff. So monsoons, common misnomer, monsoons are not related to hurricanes. Monsoons actually start off over land, but they do occur in coastal areas. Basically, it's a lot of air movement. You have those different temperatures that we've talked about. It usually happens in, the rainy season. But the thing about monsoons is that it's just a lot of rain at once. So here you can kind of see how the air would be moving to kind of cause such events. And this can be what happens, all right? So in a monsoon, you have a huge amount of water and rainfall, and it just kind of sits over the top of you, which really leads to flooding. You can also see monsoons, I'm using air quotes with that, in whenever you have really large lakes and areas, bay areas, inlets where you still have a lot of water, but up along a coast. And what can happen here is that you can get sea and land breezes because of that. You can also still get, torrential amounts of rain and all that good stuff. This is important, the rain shadow effect. It sounds scary, but it's not. It's actually really common sense. Think about mountains, okay? Clouds, if they build up on one side of the mountain, mountains typically are going to be too tall for those clouds to cross. So what that creates is what we call a rain shadow effect. So what you get is you'll get a lot of rain and all that on one side of a mountain chain or a mountain region, and not on the other, because those clouds literally, it's an obstacle that they cannot move past. So here's an example. The side that where you does get the most rain is called the windward side, because that's where the winds come in. And then on the other side, where it's much drier, you have the leeward. If you think about the Rocky Mountains, everything to the west of the Rocky Mountains is typically greener and has better forests, but everything on the east side of the Rocky Mountains tends to be better pasture land because there's not as many trees and stuff like that. All right, tropical storms. Well, we know 2020, where you get a lot of them. Okay, so tropical storms obviously happen over water, okay? You have the winds, they meet, and especially whenever the trade winds occur over really warm water, and that air above it gets warmer, okay, and it creates its own kind of like low pressure system. And as it does so, it continues to get water from the ocean that evaporates up and then recondensates in the clouds. And this wind circulates, and that's how we get tropical storms. In the northern hemisphere, note, in the northern hemisphere, they are clockwise. in the southern hemisphere. They move counterclockwise in the southern hemisphere. This is super important. And the fact that they are over water is what fuels them. So the difference between a tropical storm and a hurricane is the strength of the storm and the winds and the rain and all that. If it can sit over water and basically incubate for a long period of time, chances are it could become a strong, strong storm. So hurricanes do form. Hurricanes form from the Atlantic Ocean. Again, important fact. Hurricanes, they span in strength. You have like our category 1 all the way up to a category 5. So the category 1 is not nearly as intense as the category 5, which was something like Hurricane Katrina. Basically, you have the winds, and it comes from the ocean surface, and those rotating winds as it builds, and there's always that heat energy there as well. Once they hit land, they do dissipate in their strength because now they're not over that water to help maintain their energy. All right, this is kind of what the depiction of what a hurricane looks like. Now, what's the difference between a hurricane and a typhoon? Well, we said that hurricanes form over the Atlantic Ocean. So guess what? Typhoons and cyclones form over the Pacific Ocean. So it's the same thing, literally same meteorological phenomenon, just a different name because it happens in a different place. So if you notice here, we have a hurricane versus a typhoon. And here on the left, where do you think that this is? I'm going to let y'all think about it. And then over here on the right, hurricane versus a typhoon, Atlantic versus Pacific. So again, very similar. All right. Don't know why the font changed. Okay. So now let's talk about El Nino. You've heard about El Nino, you've heard about La Nina, and all that stuff. So El Nino it's a meteorological phenomenon again, but what it does is it's how the atmosphere changes, and not where you think it would, but it can create big weather changes for like a series of months over a certain area, like here in the United States and South America. So it all starts in the Pacific. Yeah, specifically in the Pacific. So what happens here is you get warm surface water, right? That's always what it starts with. And as it moves and it kind of meanders out into the Pacific, it meets up with cold ocean water, and that's down underneath. Right? So what happens is cold sinks, warm rises. And this really starts to change the area and the temperature overall. And as those winds blow back towards us, we get weather changes. So El Nino takes place right now. They're estimating more closer to every 3 to 4 years versus up to 7 years. They don't know if it's due to climate change or not. That's what they're leaning towards, though, as for that reasoning. El Nino does last for about a calendar year, at least a few seasons of a year. So what happens is you have that, basically, it kind of just flips the switch on itself. The trade winds don't blow nearly as strong. You get a lot of, along the coast of like Central and South America, you don't get as many nutrients brought in because of those trade winds are not blowing as strong. And then again, like I said, you don't really have a lot of, it's going to change us as well. And I'll get into that. So if you don't have upwelling, so let's say you're a fisherman off of the coast of, somewhere in Central America on the Pacific coast. Well, if you don't have the upwelling, then you don't have the nutrients there that the fish are wanting to be able to go after. So if the nutrients aren't there, you're not going to have all of those lower level producers and consumers for those higher level consumers to eat. And therefore, you have a decrease in fish populations. Therefore, there's less fish to catch. And whenever you do catch those fish, you're more in danger of, harming the overall long-term population because, guess what? If you catch them all, what happens? There's not any more. Tragedy of the commons. So here, this kind of shows you the normal conditions versus El Nino conditions. Picture of the old man blowing the wind is a little creepy. Now, what happens here? Okay, so let's talk about it. Here in the United States, and El Nino up northern U.S. and Canada, they actually have warmer winters. We don't tend to have quite as strong hurricane seasons. And in the eastern U.S., regions of Peru and Ecuador, which are normally pretty dry, that's where we get higher than average rainfall. The other side of the ocean, on the other side of the Pacific, the Philippines, Indonesia, Australia, Singapore, those areas, they actually are drier because of those lacking in winds. Now, what's La Nina? La Nina, it's the opposite of El Nino. So you have, you end up getting colder waters in Central and South America. And that can cause different results. All right, now, that's it for this presentation. Woohoo! Good job.